So, hi. Cool. My name's David Campy. I'm here to talk a bit today about Agile testing. I think my intro is still say I'm from Allen Gray, so first in the interest of testing our requirements, I coach at Allen Gray in the morning, which is my introduction here. I also run a software dev shop across the bay in Century City called Information Logistics, and we do mostly startups. So I'm between corporate software engineering and startup software engineering. But I've come to play with quite a bit of the software stuff, and something that's really important to me is this concept of agile testing. So today I'd like to go a bit more in depth on that. I need some of your help to understand what level of audience is at as we get through. So to kick off, someone at the door. Let's do it open. No, rather leave it open and then they can trickle. So, why do we test? Why would you test software? Okay. So we want to check if there are errors. What are errors? Bugs. Okay, what's a bug? Okay, that's a very complicated answer. If it's not working the way you want it to, it implies you know the way you want it to work, which is an assumption we often make. Other reasons that we might test.
That'd be hard, like documentation, like a specification of how you want it to work.
Okay. So we might want to document the way you want it to work.
Yeah.
Okay. Why else might you test? Performance. Yeah. Performance, which is a soft side, in my mind, of the way you want it to work. You want it to be nice and quick.
So that you don't break it.
Interesting. So that you don't break it. Would you want to test it so that you do break it? What would you learn from breaking something? Yeah. You'd learn where your assumptions lay, maybe. There's lots to be learned, yeah?
Yeah, you want to see that it breaks in the way you, like if you give it wrong data, it breaks in the way you expect it to break.
How it breaks, yeah? So this question of why is very interesting. And most of what we've been talking about now is testing after you've built it. So we get into this when. When do you test something? All the time, right? What does that mean? Okay, so after you complete something. Maybe one of the people who lecture here could help me out with the answer to this. How long has this building been here?
Oh, goodness. Way before I was a student. So it was the old chemistry building when I was a student. So when it was a new chemistry building, I have no idea.
Okay. So, and the ComSci faculty was founded?
ComSci department 72, I think.
72. So that's kind of at about the time we started to know about code and we started to write stuff. But I was really interested when I was reading from Deming a while back, when he talked about the software of a company being its processes, how it does things, the conversations that it has, how the whole company works. Like the software was the non-hardware of the company. And so if we think about the bigger picture of what the software we're building is, we're writing code that sort of frames the software of a company. If we say we test something after we complete it, that's one time to test it, right? So just looking into this, can we get some other, now I've been poking around a bit, when else might you test your product, your software, your ideas? How else might you test it? Okay, so we build a prototype. Then after we complete the prototype, we go out and we test our prototype. But we still want to test it, right? You're looking confused in the back?
No, so I would test it while I'm making it.
Okay. So how do you test something while you're making it?
So I typically write the test as I go along.
Okay. So like how just to, like for the space, how would that work? How would unit tests work as you go along?
So typically I don't write tests first, but I write my program that I see I want to do these behaviors. So I write the unit test, and then before I commit, I run these unit tests and see that it pass.
Cool. So we've talked about an initial after complete, and you also touched on test first. Test first is another place that we can think about. And we're fortunately in a building which has science in its name. So if we're thinking about science, we're looking about setting out an experiment, conducting an experiment, and looking at the results. So test first is kind of the same thing, and we'll get into a bit of that shortly. For me, it's quite useful. The when of test first is also very fascinating. Sorry, my language. Because if you look at industry now, people like startups are really cool. Startups is kind of how much of America does its research. You get some money, you go and you try a hypothesis, and you come back and you say, did it work or didn't it work? And people have found that startups, untested startups, haven't really worked all that well, and we've come up with the lean startup idea with customer development. So I'll get to there as we move through the talk. So customer development is about figuring out what people might want, how they might use it, and then helping to test, actually before you build, that people will use it the way you intend to use it, that people would actually be interested in this thing through landing pages and search results and more stuff like that. So testing is an epically huge thing, and I'm only going to touch on a few things today and tell a few stories through the world of testing, when we test and why we test. So back on why. We talked about making it the way we want to work. My question of when takes us back to this lovely little phrase, which is, are you building the right thing, or are you building the thing right? So whenever we're testing, if we test first, sometimes we can actually help understand, are we building the right thing? And the earlier we test, do we test by interrogating someone that's just told us to do this thing? And a lot of this involves stepping up, and people will say only senior software developers can do that, but it's kind of bold. Anyone can say, like, why are we building this? The emperor has no clothes on. Like, where are we going? And so you can pull earlier and earlier in the cycle. And it's very important that the sooner we can make a decision about something, it's almost intuitive, the sooner we can make a decision about something, we want to fix it. Which is why when in my first talk I talked a bit about Agile, and Agile really looks into iterative methods. So if we iterate, we're quickly producing something which can fail. If we fail, we learn and we proceed. So short of those iterations there's like an inbuilt test net, but we can do a lot better than that. So we've got quite a nice few thoughts up there. I'm just going to jot down the core tensions of the manifesto and some points on the XP radar so we can take a look at things. So the manifesto puts, well, anytime a software person reads it, it puts working software over docs. So docs are important, but they must support working software. I'll put that up first today because someone actually mentioned that you might want to test as documentation. So what form of documentation could support your working software? Well, executable documentation, of course. And how do you execute a document? You check the specification matches. Lots of depth there. And I'll touch a little bit on acceptance test-driven design today, how you can get those tests to actually describe the behavior of the system at a level that they're not actually dictating what we should be doing. Then we talk about collaboration over contract negotiation. ties quite closely into this idea of docs. If we're building with tests and we talk about how we're going to verify this thing works, we can work together to actually be able to say, the tests are passing, we did what we expected. Yes, there are a whole lot of new things we didn't know about, but the things that we set out to do, we've achieved, we've got our learnings, and now we're looking to learn new learnings. And we can invalidate, we can fail, and we can explicitly be conducting experiments that might fail. Then, responding to change over sticking to a plan. So, another important thing here, and that this is where it starts to run perhaps in the face of intuition, is that if you have tests and you've got documented tests of what you've built, you can change. If you don't have a way of verifying that the behavior is still what you built up front, it's very hard to change. Because you change something and now you have to, A, involve a lot of your brain to actually think about the repercussions and go through what this could have changed. And brains are fallible, humans are fallible, so we will miss things. And then it's expensive and we get punished for changing because we've changed something and we didn't know what was happening. So tests at the high level, acceptance tests, tests at medium level integration tests, and tests at the lowest level of unit tests, each of those helps us to verify that what we're building still works so we can grow beyond the complexity of what we can keep in our heads at any one time, which as I get older and older, I realize is more and more limited. And then when we looked at the radar last time of XP, there are three practices of XP that relate directly to testing. On the inner circle, which is the circle where we talk about the process of actually creating code, we had TDD, which is test-driven design. Talk a little bit about that. On this middle circle, which is a circle about how do we work together as a team, we had continuous integration, which is how do we integrate between multiple teams, between multiple people's code, and run those tests often. And on the outer circle, we have this rather confusing customer tests, which can mean that the customer pushes the button all the time to test, but in the interest of remaining agile, we want those tests to be automated so we can re-execute them at any time when we make a change. So we look at automated test-driven design, we look at acceptance tests, we move into SpecFlow and Cucumber and all of those cool tools that we can use to specify the behavior of a system that can be executed after you change how the system works to check, does it still work in the same way? And if it doesn't, do we need to change how we expected it to behave, or do we need to fix how it's working at the moment? So, yes?
I didn't quite follow that change of a plan bit and how tests fit it in with that.
Okay.
Are you saying that if you've got tests that somehow facilitates change?
Yes.
How?
Okay, so we'll take a little divergence to talk about this. I'm trying to think of a metaphor on the spot, but we're coding, right? And I'll do a worked example a little later, but if you wish to make a change to a system, either you make the change and it breaks, or you think about it for a really long time, where long is estimated to be long enough to have thought of all the things that could go wrong, and then you make the change. Or you have some sort of a safety net that says, this thing still works the way I intended it to work, and that's where the tests come in. So a really interesting question, and also comes down to how you can write testable code in a way that is component-based. And again, I'll try to, through example today, sort of break that out a bit. But if you know that everything works the way you thought it would work before, then if it doesn't work, it's surprising, it's new information. You can write a new test around that and check that the new behavior we found will never change. And we don't want that behavior to change, and we want to only specify behavior in our tests that shouldn't change. The 1 + 1 = 2 is generally supposed not to change unless we change some of our fundamental assumptions. And it can change. Sometimes we don't want that to be always true, and so then we need to change that. But as we build up a system, and once we've got those little green lights going on, saying everything works in our unit tests, and then our functional tests that run a bit slower and we run slightly less frequently, and ultimately in our acceptance tests, we've got the safety of knowing that things still work, because we have unintended consequences, and we want to avoid those. I hope that addresses. Yeah, cool. So, kind of implicit in all this is, or are a couple of concepts. The first is that we're talking about agile dev. So traditional dev takes the phases, I'll keep this simple, of analysis, never abbreviate analysis, it doesn't work, development, and test. So waterfall says do the analysis, finish that, then do the dev, finish that, then you can start to test and finish that. Now, this might be on a time scale in traditional waterfall of, say, a year. No, we make sure our analysis is right. We spend 3 months doing analysis, we cover all the corners of the problem. Then we spend 6 months doing our development, we build what we were building, then we spend 3 months doing our testing and exhaustively test it and make sure it works. Now, in reality, of course, dev takes longer, so dev goes there, and test gets shorter, and test becomes more and more of a buffer, and we don't do the great testing we intended on doing. Of course, when we get to testing, we realize our analysis was wrong, and we start throwing poo at each other because the analysts didn't know what they wanted, business didn't tell them the right thing, and we expect business or the client or the stakeholders to have been able to know what they wanted. And they can't know what they want because we're in a process of discovery. So it is possible for people to know what they want in a very limited number of software applications. And in those spaces, we can comfortably go with a waterfall approach. And traditionally, you see that in military environments where people are looking, they're so risk averse and they've done this so many times that they want it. Now, if we look outside of software engineering, at traditional engineering, I know I want a bridge from there to there, and we built billions of bridges, and we know exactly how things must go over these bridges, not billions perhaps, but hundreds of thousands, at least millions of bridges. The parameters are very limited. If we take the variability and the unknowns of building a software product, and we try to put them through this defined process, things go kind of wrong. And when the guys who came up with Scrum headed through to the Department Research Lab, and they said, well, this is the waterfall method, and we're proposing a new one, but let's explain the current method. That apparently these very austere scientists actually broke out of chuckle. And they laughed to say, how could you attempt this defined process with undefined inputs and outputs? If you don't know what you want at the outset, and you don't know what you want at the outcome, how are you going to be able to define it well enough to be able to build it? And so that was kind of validation that if we, instead of doing this, we go with a thin slice that says, let's do the analysis, do the dev, and do the test. Let's do the analysis, do the dev, and do the test. And each time we finish with that, feed our learnings back into the top. We can quickly course correct. Now, there's quite a bad and famous graph that says, if this is time, and this is cost, and this is the end of the project, this is the cost of fixing a bug based on when the software was written to when it's shipped. The cost goes up over time. Are people familiar with this concept? If not, I'll add a little bit more. So the idea is that if we find the bug when I'm busy discussing it with you about what I want to do, how much does it cost to fix that? So if I say, okay, so it must turn red and then green, and you go, wait, there's this orange step in between, and I'm in the UK, it must go red, orange, green. What's the cost of picking up that information? About 2.5 seconds, right? Because we picked it up early. If we pick it up after we've decided in the waterfall model on how we're going to build it, we've written up the spec, and we're here, and we're like, okay, now it's time to write it. We haven't tested our spec. When we get here, if we do, and we are diligent and we test our spec, we evaluate it and we run it through, we find that then all we have to do is rewrite a document. Now, by extension, after you've written code, it's much more expensive. After you've exhaustively manually tested, it's even more expensive. So we want to find bugs earlier. So, of course, we do waterfall so that we can find all the bugs over here at the end and multiply those by this epic cost and really just damn it ourselves. or was being facetious, okay. But if this is time and this is number of bugs, what we'd really prefer is finding them early, which is why we iterate, which is why we write small tests, which is why we test early. So we want to try to do this, and through practices that enable us to do that, we can win. And winning is what it's all about. So practices. There's this concept that's quite widely used, that there's a pyramid of tests. So, and I like to make a pyramid three-dimensional because it helps you to understand that there's actually, in addition to the linear thing, there's actually a square law with the number of tests we want to have. So when we look at the bottom level, this is when we look at the number of unit tests we expect to have. So a unit test is something that is so small that you think you shouldn't write it. It checks that a function returns the value based on the parameters, and we look for ways to isolate that. You pass only those parameters in, and you get only that result back. It seems like that test shouldn't have to exist, but it does allow you to change the behavior of that function and add additional tests, knowing that the initial behavior still works. So those unit tests are tiny, and they're very closely coupled to the code. Then we get into functional tests. Now, a functional test is the kind of test everyone imagines when they first encounter testing. It's the test that calls to the database, gets the data back, checks that things work. May not actually show it on the UI because we're thinking about using a test automation tool, so it might call in, get the values back, and give you some useful information about what's happening. And it's useful. If it breaks, it's less useful because it doesn't tell you exactly what's gone wrong. But it's still useful. Then after functional, we get system tests. So these are tests that bundle the whole thing together, take everything and run it through. Sometimes, actually for me, it was the first type of test I ever tried to write, which is really, really crap because you write that test and it fails and you don't know what's going on. At least you know your system's broken, right? Before you couldn't know your system was broken unless you manually test it. So if you've got an automated system test, at least you know something's gone wrong in this great, wonderful world of my system. And if you've been running this test regularly, you know that it's something I've changed recently, so you can go back and investigate that. These are the most likely tests to go non-deterministic, though. And I won't cover non-determinism in tests today, but once a test goes non-deterministic, it's kind of like a virus that will infect your test suite. It's horrible because you can't trust that test, then people stop looking at the test results, then there's no value to the whole test results because they failed, but it's probably that stupid test again. But it wasn't, it was something else, but I never looked at it. So I'm not going to get into how we resolve non-determinism in tests, but that's where we are. So I'm going to tell a few stories on these different layers, and then I think if I have time, I'll do a worked example, but maybe not. So let's look at unit tests. How do unit tests actually end up in the world? Unit tests end up in the world as wild as test-driven development in some cases. Not in all. First time I started saying I was unit testing, I didn't know what unit testing was. And I'd been asked by my manager, I told my managers we need to unit test because I heard that the practice was good. And I kind of had an idea. I kind of got given some time to do it. I tried to do it. I realized it was hard. And so I stopped doing it because I was a developer and I can really do anything I want. And so that thing never really happened and we blamed it on project management. And it's kind of because testing in general and test-driven development in specific are one of the few things in software engineering that are genuinely hard. They're hard not to actually do, but they're hard to learn. When you're a dev and a professional dev or in academia, wherever you are, most things that you have to learn can be learned by reading a couple of paragraphs, understanding it in your head, and then going out doing a little bit. Most of these things can be mastered to a level of competence in less than a day. two practices that always bite for me is pairing and test-driven design. Those two are things that we work on constantly, and mastery is a really long way away. But at every step we take, we get better. I won't pretend to have mastered either of those, but I'm a lot better than I used to be. So, unit tests. I started out on this project. I was supposed to be doing unit tests. I never really did. They were run. We had a nice daily build that ran and made sure things still built. That's the first level test. Does it compile? This was, if people were here last time, the same project, the Microsoft project. Someone had set up a build server because Microsoft had just released Team Foundation server and it was a good idea to use it. Didn't really understand how to write tests, but we had some. We were running them, and yeah, things were okay. Then I kind of got test-driven, and today, when I think of a little startup I was working on, I'm the only dev there, so my test. But I found that it didn't work. I'd become so used to test-driven that I couldn't make progress without having tests. Well, it was hard, and dev isn't that hard if we use tests. And the reason that dev stops being hard once you have tests is you don't have to have so many things in context at a time. So if I'm writing code, Bolt is the name of this application. I can't tell you anything else about it, but I want to achieve a new objective. In test-driven, I write a new test to say, I would like to be able to add someone's name. And then I go about making that pass, very simply, and then it passes. Now, I'm simplifying because of time and context, but each thing I'm doing generally only involves a few lines of code to make the test pass. When Corey Haynes teaches TDD, we do an exercise called TDD like you mean it, which means write a line of test, go and write the line of code to make that pass. Go back and write the next line of test, then go back and make that pass. Go back and write the next line of test, and so on. Every line of test needs to be able to be made pass. So even instantiating a method, well, now I can go and write code. But you're not allowed to write code until there's a test that needs it. So that leads us to the red-green refactor pattern, which is get the test to fail. So write a failing test, get the test to pass, then change your code so that the light still stays green. But if I want to optimize something, first get it working, then optimize it. So interesting pattern on the red-green refactor pattern. And if you're getting started, it's a good little mantra to keep in your head. So the two things that stand in the way of unit testing and TDD are, one, the law of Demeter, which says only give something as much as it needs. If something's pulling stuff from global variables and from setup strings and from the operating system and all of these places, it's really hard to test because you have to set up all of those things again to be able to run that small bit of code. So rather pass it what it needs and let it give it up. So that's one place that we get into there. TDD experience and practice, do people know this stuff? Or am I on new stuff? Okay, cool. Just checking. Because I may have been on the quiet. The other big barrier to TDD is ego. And it's huge. As I said, TDD is really hard to learn because we read it, we think we understand it, and now we put up this barrier that says, I can't actually learn how to do it because I've said I know how to do it, I've asked to do it, and now I'm supposed to know how to do it. And everything else we do, we can learn very quickly by doing. TDD is one of the few things that needs some deliberate practice. And that's why the code retreat format is really cool. Shameless plug that I run quarterly code retreats over at Information Logistics. They're free. They include free lunch. They involve giving up a Saturday from 8 to 4:30 to sit and practice coding. I will not go into the whole format, but basically pairing with someone for 45 minutes. At the end of that 45 minutes, you throw away what you've just built, and you start again with someone else for another 45 minutes on the same problem throughout the day to learn the craft of software engineering. So if anyone's keen, I've also spoken to UCT. I might be trying to run one on an alternate cadence out of the Honors Lab at the end. Or initially, you're welcome to start coming to ours. They're all on meetup.com. So that plug is there, and I make nothing out of it. I actually buy lunch for everyone, but it's because I enjoy getting better at craft. So if you're keen, that's there. So functional, as I said earlier, is a common start. I've been branded as being from Alan Gray. So a story from Alan Gray now is that they deal with an external system called Flex. And Flex, they have functional tests that call through into it. But there's no, because we're running a functional test and not a unit test, we run into non-determinism, because the database that you're calling into can change. Someone else's test can change what you're looking at. And it becomes, very quickly, the tests become useless. People end up writing clever fixtures to find something in the right state that you want it in to be able to modify it and carry on. So we're looking at ways of removing that non-determinism, but that non-determinism in tests is a great paper. If you're interested, Non-Determinism in Tests is the name of the paper, and it is, I'll get his name for you shortly, it's just in the back of my mind. So we struggle when we're dealing with external systems the second we move above unit, because sometimes non-determinism gets introduced. Moving on to customer tests. I was writing a financial services platform, and we were really struggling. The analysts kept saying, the devs don't know what's going on, and we had to write tests, and we thought we were doing the right thing. We wrote these end-unit tests, and they were cool. We wrote tests with large fixtures in, by large, I mean, I'm showing you the length of the method in like lines of code. We had every database value going in, everything coming out, how it was going to be, and they were really good tests. The problem is that only developers could maintain them. And this is where we get into this circle of customer tests. So the customer being able to run these tests and describe these tests is really important. And that's where we get these different specification languages. In this case, we use something called Fitness, which is basically a wiki on top of the framework for integrated test. And that wiki lets you specify your tests in tables. So we're like, okay, Mr. Analyst, people here. We write this little fixture. You can put a table in this little fixture, and the input results and the expected results, what will come out of our functions. And this is how you write the tests, and please write some. We're very handy-holdy. We went away, we started deving, we came back, and there were 60-plus fixtures that they'd written. They'd started to write how things should work, and they'd started to write these acceptance tests that told us, this is the bit, okay, I put this in, this came out, that result there, that's wrong. They could put their finger on the button for us because we'd given them a specification name. And that was an unintended consequence for us of opening that up. And pretty soon they realized that this was just a wiki, and that they could actually specify fixtures that they would like, and say, okay, well, we'd like to be able to fire things in this way, like based on day of week or based on this. And then they'd say, can you write a fixture like that? You never ask that to a developer, because the answer is yes. So then we'd rise to the challenge, we'd build these fixtures, and quite quickly we built this set of fixtures which allowed us to specify the behavior of the system from a business perspective, and they could read these tables. And we actually felt quite bad, because these guys were copy-pasting like vast tracts of data into the system. The nice thing with Fitness is it's got export to Excel button, and that's like duck into water for a lot of business people. So there was a ridiculous success story for us out of a very sort of, we'd heard it was a good thing to do, these acceptance tests and the customer tests. We were trying to do them by getting them to write it on paper and do it in in-unit. The second we gave the test a tool into their hands, we were really blown away. So these days we've got Cucumber, we've got SpecFlow. I think there's many of them, ways that allow you to develop a domain language so you can actually express in an English-like way the behavior of the system. And if you want buzzwords to Google, I mean, if you look in behavior-driven development or acceptance test-driven development, that's where you'll find the discussions about how these things work at that top level. Then moving into the inner level, we've got, so in between the customer specifying behavior and us doing these unit tests. So this, all the way up here, is like the tests that we write. And you write those tests, it's very cool. You can click a button, all the tests run, and stuff happens. Soon, though, some of those tests take a long time. You never want your unit tests to take longer than, say, 30 seconds to run. If they're taking longer than 30 seconds, something's wrong and you need it out. Your functional tests, like if they take 1 to 5 minutes, it's okay, they might be useful. Your system tests could take 8 hours. They could run overnight. They could do daily runs. Sometimes they take even longer. So it's not a very common development. It's going to click an 8-hour button and go for a very long cup of coffee while stuff happens. Or he clicks it and you have to wait for the feedback. Or she clicks it and it breaks halfway through but doesn't get feedback. Or we click it once or release. So that's where this idea of continuous integration comes from. So if you've got automated tests, why not get a robot army to run them for you? And so we enlist slaves, which in most of them you actually call them slaves. You run a build slave on a machine and you say, okay, the build master is going to say, you check this code out of the repository, run the tests, collate the results, build these graphs, and put them up here. There's a couple of tools. I mean, the most common ones are Hudson and Jenkins. ThoughtWorks has something called Go. There's an interesting tool set. I'd look into Jenkins first because it's pretty simple and general purpose. At Allen Gray, we're using Hudson, which is the commercial version of Jenkins. There was a split in the Holy Writ at some point, but Hudson, really, it just runs on a server. It's got a bunch of little green lights next to the builds saying each one, all the test results have passed, and it will run them anytime someone checks code. It's such a simple idea, but it's pretty amazing because it means if you forgot to check in a file or you left config settings out and you haven't checked those in, those never get inflicted on humans. And we really don't want to inflict much pain on humans. So we get the build server to run it. It's all okay, we're happy with it. And preferably, before anyone else has touched it, you can see it's failed, get a mail back to you saying what you just checked in failed, and go and fix it. So the nirvana of continuous integration is continuous deployment. And IMVU, which is a 3D online chat, quite famously has used continuous deployment, where you check in your code, it gets run through the automated tests, then it gets, once all those automated tests have run, kind of understand it's okay. It then gets released to a small subset of the users. It's different every time. But the actual users using the site get a small subset of it, and then they monitor performance, they monitor connection drops, and they monitor all those things on those people, on those users. They put it onto one of their servers, and they see the server utilization. Then from there, they slowly move it up until it's deployed to the entire user base. And they're getting about 80 deploys a day at a maximum coming through the system. So they don't have a 2-weekly cycle of deployment or a monthly cycle or an annual cycle of here's your new version of the game. As the things are fixed, it goes on. Twitter, YouTube, they all use very similar processes to just keep getting those changes out without having to have complicated human processes for getting things through. So that covers our 3 main weapons, which was unit testing or your sort of test-driven design practices, then continuous integration, and finally customer tests. So I think for me that is a responsible introduction to Agile testing. It is a huge field and a very hard field. I was hoping maybe to do a little example today, but maybe I'll bring that in next time. Maybe have a focused TDD session. Maybe we'll do a laptop session next time, or take it to the lab so we can actually do some practical TDD. There are a couple of great sort of canonical examples that help in your first iteration of getting into TDD. Yeah, so I'll do those exercises next time, or at a future time if there's enough interest, but I'll run that as a specific branded session. And another shameless plug, if you guys are keen, look up Code Retreat and Meetup. And we get about 10, 15 people at a time. Our maximum capacity is probably 20. If we go over that, we'll find another venue. So don't be shy if you're keen on getting better at coding. And thank you. Any questions? Wait, before I do that, let me just recap today, because that will help the questions too. So we started out with why do we test and when do we test? We test to make sure we're building the right thing and we're building the thing right. When we test is ultimately all the time. Before we build, after we build. Before we specify, after we specify. Before we release, after we release. All of these give us opportunities for testing different behaviors of systems. In the core values of the manifesto, we find justifications for testing. We find testing across the three rings of the XP radar. At each level, there's space and necessity for testing. By testing early and testing often, we can minimize costs. Minimize the cost of fixing bugs, finding them early, minimize the cost of losing trust, and minimize ultimately the cost of building the wrong thing, which is what we want to avoid. It doesn't matter if you spend 2 years and you build it exactly what you wanted. If it's wrong, it's wrong. No one wants it. Then we went through building together the pyramid of unit functional and system tests. And of course, I've left off on the top of the pyramid our manual tests. There's often need for some manual exploratory tests, some human on the top, but once it's gone through all of these non-human processes, then we can feed it back to a human and not waste their life. So, yes, that's a good way to summarize today. Agile testing. Don't waste your life. Questions?
So, you were talking about what's called monitoring tests. So
Yes.
Have you looked at mocking where you...
Yes. Yes, so mocking is a way of pushing a test down the stack. So if you mock out a functional dependency, you can then get down to more of a unit test where you can determine what the inputs and outputs are going to be. Yes, very much practical technique. Yeah. That's one of them. There's quite a few ways of doing it. We start out by quarantining them and do stuff. So, cool. Anything else? Covered a lot. So.
Can you? Is it possible to give us like a board example of what what some cucumber syntax looks like?
Sure. It takes most of the BDD style stuff. So it says, given a basket with 3 eggs, when a shopper takes an egg, then the basket has 2 eggs and the customer has 1. So what you're really doing there is you're writing a domain-specific language for that stuff that says, okay, given a basket with 3 eggs, when we execute that, we're going to read through and we're going to have a cucumber function that says, okay, this is a given. When we see a basket, we're going to new out the basket with 3 eggs in it. We're then going to take the word with, interpret that as it's time to pass in a parameter. What are we passing in? Let's tokenize and understand 3 eggs. So now we've newed up basket with 3 eggs. It's human readable. The step before this is to write fluent tests. So given a basket with 3 eggs, when we didn't call a method, so we're going to have a shopper. We probably would have either put the shopper in our given, but I'm just trying to simplify it. So given a basket with 3 eggs and the shopper, when the shopper takes an egg, then we say, okay, shopper is now going to call method take egg from basket. Then, so it's basically specifying this DSL to let us translate into our program code. But the nice thing is if I want to change the function from called take egg to receive egg, it doesn't matter because I've still written this in the same way. I can change the parameter order of my functions because my tests are specified at the layer below this. And this is very human readable. Does that clarify this?
It does, and so you find that that's something that people who aren't developers are able to work with and not break.
Yes. So before you even start doing that, now I'm personally of the opinion that even making that automatable is a step further than you need to start. We start by doing BDD and just write down what we expect, and then at the end we can execute those assumptions, at least by reading it and saying, okay, let's do this, does it work? Yes, okay, so now we've got a human interpreter. Once we're comfortable with BDD and we've done it as a practice, then we can move into automating. But the joy as a developer is jump straight into the tool, but sometimes let's just step back and learn how to use the process first. And writing given when thens is a great way to specify scenarios, and then you can automate that.
So BDD has sort of standard terms that these kind of line up with.
Yeah, your given when then is, if you're looking at the core of
Okay.
BDD, it's not complicated.
So your analyst then has also got to be familiar with that language.
Yeah, generally you start to educate those, and some people get jaded on that language, so you can try something else. You can say, for these people. So there's two specification languages used in Agile. There's common ones, BDD format, given when then, and then the user story that says, as a type of user, I want to achieve this, I want to do this thing so that I can achieve this outcome. Again, that's a very simple and succinct way of phrasing something, and the idea is that the user story is a reminder to have a conversation and a way of capturing intent. Cool. Anything else? Yes. Matt. Cool. I'll be here for a while afterwards. I've got to dash back, but I'll be here for at least 15 minutes or so. I'm not going to go for lunch.
When is the next meeting?
I don't know when my next slot is scheduled, but